Alright, so for this lesson, we're now on Chapter 1, Section 2. This is Order of Operations. So, we're going to be focusing on how do we solve these equations step by step, given we're interested in multiplication, subtraction, addition. We have to keep those in mind and pay attention to any exponents or parentheses we might come across. So we've already talked about taking things algebraically and expressing them verbally, and also doing the opposite, taking a verbal expression, writing it with variables and numbers. So now we're going to take that a step further and evaluate these numerical expressions based on the proper order of operations, which is just a fancy way of saying PEMDAS. The difference between numerical and algebraic expressions is just numerical meaning numbers, algebraic meaning like algebra. That means there's going to be some sort of variable involved there. So the first example we have is example 1a. We're asked to evaluate the problem 2 to the 6th power. So this is what we would call a numerical expression, and all we have to do to evaluate it is know what the power is telling us to do. So to the 6th power means 2 times itself with 6 factors of 2. So if we write that out, it's 2 times 2 times 2 again, and you keep going until you get 6 factors of 2. So 2 times 2 will give you 4, times 2 again will give you 8. You keep going in that way, you get 16, then 32, and finally you would get 64. So 2 to the 6th power is really just a fancy way of saying 64. So this is example 1a. Your question is 2 to the 6th power. Your solution is 64. Now moving on to the next example. We're asked to evaluate 4 to the 4th power. Now when they say evaluate, that means that there's a definite solution to that numerical expression. So 4 to the 4th power is 4 times 4, and you do that until you have 4 factors. So 4 times 4 gives us 16, 16 times 4 gives us 64, and one more time would give us 4 to the 4th power, which is 128. Excuse me. So that's 3 times. So 4 times 4 is 16, times 4 again is 64. One more time is 256. So we get 16, 64, 64 times 4 if you try on a calculator is 256. So your answer there would be D. You don't need to write out A, B, C, and D. You only need to write the question, evaluate 4 to the 4th power, and your solution 256. Now here we're talking about order of operations. That's the idea for this section. You don't need to write this down because we've all heard PEMDAS over and over and over again. So we know that here we need to evaluate expressions by doing what's in parentheses first. Then we'll evaluate any exponents, meaning any powers. We'll multiply or divide. That's the M and the D in PEMDAS. And then the last thing we would do is add or subtract. So we've all heard that multiple times. We know how to follow order of operations. This is just an introductory type lesson so that we have the foundational skills we need going forward to succeed with the higher level difficult material. So you do not need to write this down, but you do need to understand the order of operations. If you're still struggling with this, make sure you get with me at some point to practice any skills you might need. So example 2a, we're asked to evaluate another numerical expression. It's a numerical expression because it only has numbers, there are no variables. So here we see there's several terms that we have to deal with. And the way we solve this problem is by making sure we do the operations in the order of significance that we know. So following PEMDAS, we would do parentheses first. Since there are no parentheses, we'd move on to exponents. So 2 to the 3rd is the first thing we need to evaluate. So I would replace 2 to the 3rd with what that is equal to. 2 to the 3rd power is 2 times 2 times 2, which I know is 8. So we evaluated all the powers. We get this expression now. Now we can do any multiplying or dividing that we need. Since we finished the P and the E in PEMDAS, now we're at the M and the D. So let's multiply or divide. So we can divide 48 by 8 and also multiply by 3. So 48 divided by 8 gives us 6. And we know we can do 6 times 3, which will give us 18. So now we've done parentheses, exponents. We've multiplied, we've divided. Now the only thing left is add or subtract. So let's go ahead and add 18 plus 5, and we get 23. So the whole point here is to follow order of operations, because if you add or multiply things out of order, you end up with the wrong solution. For example, if I go back to the beginning of the problem, if I were to then say 3 plus 5 is 8, and then I did 8 times 2 to the third, I would end up with a completely different answer. So you have to follow the order of operations in order to get the right solution. That's why we're doing this whole thing, because doing it out of order gives you the wrong solution. So here's your problem. These are the steps. The solution is 23. Now, moving on to our next example, we're asked to evaluate yet another numerical expression. So it's going to be one of these solutions here. We know we need to evaluate anything in parentheses first. That's the P in PEMDAS. So everything within these parentheses, I'll evaluate that first. So I know 9 squared is going to give me 9 times 9, which is 81. 81 minus 9 is what's in parentheses. 81 minus 9, I know, will give me 72. So 72 is in parentheses. It's divided by 12. All that's in parentheses. And then we're multiplying it by 5. So I know I can do it in a calculator, or I can just do it by mental math. 72 divided by 12 is going to give me 6. And 6 times our 5 on the outside would give me 30. So if I evaluated this correctly, our final solution when using proper order of operations would be C30. And that is in fact the answer. So when we evaluate that expression, our solution is 30. So what you need to make sure you write is the expression here and just the solution 30. No need to write the other options there. This is just part of understanding this interactive presentation. So we only need the question and the solution. So now we're evaluating a more difficult problem. So we've got grouping going on, which really just practices our ability to distribute. So we've got a parenthesis here and another parenthesis over here. We need to evaluate what's inside those first, and then we can get on to understand what the solution should be. So evaluating what's in the parentheses first, 8 minus 3 in red here becomes 5. 3 plus 2 here in green becomes 5 also. So now this whole thing becomes 5 times 3 times 5. Now all we have here is multiplication and multiplication again with these two numbers. So since it's all multiplication, we can go ahead and multiply everything through. 3 times 5 here gives me 15, and 15 times 5 will give me 75. So this whole expression, for example 3a evaluated, our final solution there is 75. Only a few steps. If we do parentheses first, the rest of it is just multiplication. So following those order of operations, we arrive at the correct solution. Example 3b, we're asked to evaluate this numerical expression. So we see we've got brackets, parentheses, and a power. So we've got parentheses within parentheses. So we have to start with the innermost one here, and then we'll do the outside parentheses, then the power, and then we can also multiply. So the innermost parenthesis, 6 minus 2 gives us 4. So we've worked that part out. Now we just have the outer parenthesis to deal with. 12 divided by 4, which comes out to a nice neat number. We know 12 divided by 4 is going to give us 3. So we're following along. We've worked through both parentheses. If we're following PEMDAS, we've just finished the P part of PEMDAS. So now we'd have to do any exponents. So we have a 2, that's our power and exponent. We need to evaluate that before we multiply. We absolutely cannot say 4 times 3 is 12 because that is ignoring our exponent. We must take our exponent into consideration before doing any multiplication. That's the E in PEMDAS, which comes before the M in PEMDAS. We cannot multiply before we evaluate the exponent. So I need to say 3 squared. What is that? Well, I know 3 to the power of 2 is 3 times 3, which is 9. And 9 times 4 gives me our final answer of 36. So notice here, if I would have said 3 times 4 is 12, and then 12 squared would have given me 144, which is not close to 36. Okay, so the order of operations matters. If you do it out of order, you will get the wrong solution. So evaluate that exponent first, then multiply, we get the right solution there. So moving on to algebraic expressions, we've got 3 different variables here to contend with. We can plug those in, replace the letters with the values we're given here, and then we can arrive at a solution. So really all you have to do here is take the numbers that they give you, replace them with the symbols that they tell you to replace them with, and then simplify your expression. Order of operations still is in effect here, so if we follow everything in the correct order, we'll arrive at the right solution. So first thing we do, everywhere we see an X, we replace it with a 4, as you see here in red. Every time we see a Y, we replace it with a 3, as we see in green. And everywhere we see a Z, we replace it with a 2, as we see in blue. So now we have a numerical expression, just like we saw in the previous examples, that we can simplify. All we had to do is plug everything in like we see there. So now we're back to using PEMDAS. We have to evaluate the parentheses first. So I need to take this 4 and square it, gives me 16, and then subtract 3 from that. So 16 minus 3 gives me 13. Now I've got multiplication here and a power over here, so I know that this power is important, so I'll make that 4. 2 squared is 4. Now we have multiplication over here that comes before anything else that's left. 2 times 13 gives me 26, and 26 plus 4 gives me our final answer of 30. So if we break that down doing parentheses first, any exponents, we multiply and divide everything, and the last thing we do is add or subtract anything that's left, we would arrive at our final answer of 30. So hopefully by now you've written the full expression at the top in blue, and our final solution, which is 30 when plugged in properly and done with order of operations. Now this is a 2-part question. This is our real world example. Most of our lessons will end with some kind of real world example applying the concepts that we're working on. So for this one, go ahead and start writing down this paragraph. This is going to be a 2-part question. So we have part A and B coming from the same example. We're talking about architecture. So in the real world, math is used a ton for architecture, which is a fancy word for designing and building buildings. So this is specifically talking about the Great Pyramid, which is in Egypt. It's a very famous worldwide landmark. So we're trying to measure the area of one of the sides of this Great Pyramid, and we can do that given the right measurements and given an expression to understand how we measure the area of a triangle. And it just so turns out that the area of a triangle is fairly easy to measure. So we know that the area of any simple triangle, as you probably heard before, is 1/2 times the base times the height. So given the base and the height of a triangle, we can find what is the area of that triangle. So part A, we want to write an expression that represents the area of one side of the Great Pyramid. So you're going to have to write this down as well. So just say write an expression that represents the area of one side of the Great Pyramid. And like I said before, it turns out that this is a very simple equation that you've probably seen many times already. The area of any triangle, whether it's the Great Pyramid or a triangular block, is always 1/2 base times height. So the solution to part A, what is an expression that would represent the area? Well, even though it's the Great Pyramid, the area of one base of that pyramid is still just a simple triangle, and the area of any triangle is 1/2 base times height. So an expression to find the area of that triangle is 1/2 the base times the height. There is your solution to part A for this example. Now part B, we want to find the area of one side of the Great Pyramid. So now we've written an expression to understand what the area is. Now we can take that a step further and actually find the area of the base of the Great Pyramid, given the specific parameters for it. So they give us the base, they give us the height. We can plug in real numbers to find out what that base area measurement actually is in physical space in the real world. So given the equation, we can plug in the values for the base and the height. So the base was given to be 230. The height was given to be 187 in our original paragraph, and you can go back and check that for accuracy. So we can replace B with 230, we replace H with 187. So given those values now, all we have to do is plug in, replace, and simplify just like we've been doing. So now we're back to a numerical expression instead of an algebra one, and all we have to do now is simplify and work that through. So in a calculator or by hand, you can find 230 times 187 to be this number here, 43,010. We're going to have to cut that in half, though, to get our final area. And we find that the area of the base of one side of the Great Pyramid is 21,505. And I believe that is, the units for that is meters. So a little more than 20,000 meters is the area of one side of the Great Pyramid. It's a very, very big amount of space. And it's impressive that culture so long ago was able to accomplish this given a limited technology at the time. So this is one application for math, is in building amazing structures. So there are many, many other applications. This is just one simple problem in your book. So there's your problem that you need to have written for example B. A couple steps, and your solution is 21,505. Label your units as meters squared. So now we've gone through all of these problems. So we know how to write expressions. We know how to evaluate expressions. Given numbers, we can plug them in and find them. So we're going to use all these tools going forward today to work with expressions in practical ways.